So we have two ways of solving a quadratic. We have graphing, which is labor intensive, involves a lot of work, and we have factoring. We can solve a quadratic by factoring. But here's my question. We don't want to graph everything. That should not be our go-to just because it takes so much work. And I'm not providing graphs, so you'd have to create your own graphs, and nobody wants to do that. But you may try to factor or solve by factoring, but what if it can't be factored? I mean, what if the product of C doesn't have a sum of B? I mean, what if you can't factor it? There are plenty of problems that we discovered when we learned how to factor that cannot be factored. That does not mean that quadratic does not have a solution. It may have a decimal value, or it may have a value that we haven't gotten to yet, right? It just may not be able to be factored. So today we're going to learn to factor by square roots. So the biggest part of being able to factor by square roots is that you need to have a good knowledge of perfect squares. You need to be able to recognize almost immediately, does this problem contain perfect squares? And perfect squares are 1, 4, 9, what's next? 16, 25, 36, 49, 64, 81, 100, 121, right? You have to have a good understanding of perfect squares. You have to be able to identify, is this quadratic? Are my coefficients or my constants a perfect square? Because sometimes you can't factor. Sometimes you can't factor. Sometimes factoring just doesn't happen. So when we can't factor, if you're B 0, or there are no factors of C that have a sum of B. If you can't factor, look to see if there are perfect squares. If there aren't perfect squares, then we have to graph it at this point. But now we have 3 tricks to use. Perfect squares, or square roots. We have factoring, and we have graphing. Now here's the kind of wrap your head around it. You have to be aware, or be okay with, all square roots have 2 solutions. All square roots have 2 solutions.
Would all square roots have 0 axis symmetry?
All square roots have 2 solutions. Except, and we're going to fill it in a second. So here's my question. If I said that x squared equals 16, what does x equal? Right, I'd find the square root, right? So x equals 4, because 4 times 4 is 16, right? What else times what else equals 16? And x equals negative 4. Every square root is going to have a positive and a negative value because 4 times 4 is 16 and negative 4 times negative 4 is 16. So we write it sometimes like this. Is a shortcut. Or you could write 4 and negative 4. Zach?
Would the would the solution to all of the problems, the x values be opposites?
Yes, if there is, the x values are opposites. Right now, yes. All right, let's try another one. I mean, just pretty basic. Let's say x squared equals 36. Right? Is this a quadratic? Yes. It's not written in graphing form because it doesn't equal 0, but that's okay. Because I'm finding the square root of x. So I'm going to square root both sides. So the solution, I have two solutions to this problem. X equals 6 and x equals negative 6. Because 6 times 6 is 36. And negative 6 times negative 6 is 36. A little more. All right, so let's talk about this one, the square root of 0. Right? X squared equals 0. What does x equal? 0. And what else does x equal? Negative 0, right? But is there a negative 0?
No.
So it's just 0. So all square roots have two solutions except 0. Because the square root of 0 is 0. There's no plus or minus. There's no positive 0. There's no negative 0. All right, try this one. What if it said x squared equals 10? Is that a perfect square?
No.
So you're going to have to use what to find the square root of 10?
Calculator.
A calculator, do it.
Okay, I'm doing it right now.
So round to the nearest hundredth.
Who just gave me a white pen?
Square root x squared equals 10. So you're going to do the square root of 10. Round to the nearest hundredth. So x equals what? 3.16.
Yeah.
And it equals negative 3.16. There are two solutions. There's a positive solution and a negative solution. Every square root has two solutions except 0. 0 only has one solution. All right, try this one. X squared equals negative 49. X squared equals negative 49. What times what equals negative 49?
Negative 7 times 4.
Well, they have to be the same, don't they? Like, 4 times 4 was 16. Negative 4 times negative 4 is 16. 6 times 6 is 36. Negative 6 times negative 6 is 36. But what times what equals 49? Negative 7 and positive 7. Are they the same?
No.
This problem has no solution.
So if they're not the same, then
You cannot multiply the same number, and get a negative.
Wait, can you graph that?
so if it's a negative number, then we can't do it.
You can't find the answer with
Negative.
square roots. I know that 49 is a perfect square. But it's a negative, and you cannot take the square root of a negative number.
Makes sense.
Algebra 2 you will. Right now you won't. No. Alright, so these problems, you look for square roots. So solve by square root if the b value equals 0. So solve by square roots if the b value equals 0, meaning you've got no x. You have an x squared, but there's no x variable. And here are the steps that you use. Oh no, let's do this. I gave you a yellow piece of paper. Sorry, I forgot.
This long.
What?
How come these questions are x squared equals where the rest of them were y equals?
They weren't y equals.
They were 0 equals.
They were 0 equals.
Question is ask the teacher standing right behind you.
All right, let's put this in. In half. Figure it out. Which way is going to fit in your notebook? If it doesn't work, yeah, I would throw it away. Solve by square root. So this is when our b value equals 0. When there is no b value. Most likely when it's in simplified form, it's going to be a binomial. It's going to have 2 terms. Solve by square roots, and this is when b equals 0. And now we'll do our steps. So this is the trick, and this is kind of what Zach was asking for. These problems are a little bit different looking than what we've been working for. And that's because I've already done some work. Number 1 is to isolate the x squared. What does it mean to isolate something? Separate, get it by itself. Step 2 is to square root both sides. And why are we square rooting? Zach, why? Yeah, the inverse of a square is square rooting, correct?
Yeah.
And then don't forget the square root has two solutions, usually, right? All right, here we go. Examples. X squared plus 5 equals 5. Is it a quadratic? Yes. Could we graph it? Yes. I don't want to factor it necessarily because I don't have a b value, right? Factors of c that have a sum of b. So factoring's kind of out of the option. So let's solve it, right? Let's square root. Because there's no b value, I can square root it. So isolate x squared, meaning get x squared by itself. So subtract 5 from both sides, leaving me with x squared equals what? 0. Square root both sides, okay. So x equals, what's the square root of 0? 0. What about negative 0? There's no such thing as negative 0, so it's just 0. This crosses the x-axis only at 0. Let's try another one. 4x squared minus 25 equals 0. 4x squared minus 25 equals 0. I could factor this. I could graph it. But because I see 4 and I see 25, I'm going to square root it. So plus 25. And what does that leave me with? 4x squared equals 25. Is x squared by itself yet?
No.
Divide by 4, divide by 4. You have two choices right now. I'm going to choose to leave it 25 over 4. Because I know my last step is to square root, correct? And I know that 25 is perfect and 4 is perfect. If this was 25 divided by 3, forget it. I'd find the decimal value. But because they're both square roots and my next step is to square root, I'm going to leave them in fraction form. Because now I take the square root. So x equals, what's the square root of 25?
5.
Over, what's the square root of 4? So is my answer 5 over 2? No. My answer is positive 5 over 2 or negative 5 over 2. There are two solutions to this problem. Mm-hmm. You can choose whichever one you want. All right, let's try. X plus 5 squared equals 121. This one's a little different. Is x squared by itself?
No.
No, it's not. So what do you need to move away from it?
5.
But I can't move the 5 because it's inside the parentheses. That 5 belongs to the x. I can't get rid of it yet because outside parentheses is 2, is a square. So in this problem, I have to switch it. I have to switch step 1 and step 2. This is a flip-flop. I'm going to flip number 1 and number 2, rule 1 and number 2. In this problem, instead of isolating x squared first, because there really isn't an x squared, right? It's x plus 5 squared. In this problem, I'm going to square root first. And taking the square root of something that's squared, are those inverses of each other?
Yes.
So I'm left with x plus 5 equals what? Not 11. Positive 11 or negative 11. So now I split my problem in two. X plus 5 equals 11 or x plus 5 equals negative 11. This is a special type of problem. Well, hopefully that draws your attention to it. What does this x value equal? X equals 6 or x equals negative 16. So earlier, Zach asked, is it just always going to be that they're opposites of each other? The answer is most of the time, yes. Your answer will be that they're just opposites of each other. You know, positive 5 over 2 and negative 5 over 2. 0. The time that they're not opposites of each other is when your value is a quantity. Your x is a quantity. It's x plus 5 squared. You have to flip it and do the square root first and then isolate your x value. Zach?
How come you didn't just square them at the beginning so it was x squared plus 25 and then subtract 25 from the second?
Because it's not x squared plus 25. It's x squared plus 10x plus 25. If you foiled x plus 5, you get a trinomial. All right, let's try one more. Okay, gentlemen, put the twirly-doos away and finish your notes. All right. First step, isolate x squared. I can use my steps in order because the x squared actually exists. It's different than this guy. This guy was not x squared. This was x plus 5 squared. So I can go in regular order. Isolate x squared. Is x squared by itself? Can you make it by itself?
Yes.
What should we do? You can either subtract 80 to leave this by itself, or I can move this by adding 2x squared. Doesn't matter. Both are going to get you the same answer. So now my problem reads 2x squared equals 80. Is x squared by itself? No. Now what do I have to do? Divide by 2. Sam, focus, please. X squared equals what? 40. Am I done now? No. I have to take the square root to get x by itself. Do you off the top of your head know the square root of 40? I know it's between 6 and 7. That's about it. You're going to have to use your calculator. What is the square root of 40? 6.32?
Yeah.
Well, that's not right.
Oh, roasted.
Positive 6.32 and negative 6.32. There are two solutions to this problem. So this problem, its axis of symmetry, because they're positive negative of each other, is 0. Axis of symmetry is 0. Does this one have an axis of symmetry of 0? If it crosses at 6 and negative 16? No, it's not in the middle. Solving quadratics by square roots.